Hello everybody, this is the chemistry exam review worksheet for grade 8, semester 1 at the International School of Innovation. Here we have some notes to study. Let's distinguish between metals and non-metals. Mainly metals, they are solids. Exception is mercury, which is liquid, and gallium. While non-metals are found in the three states: solid, liquid, and gases. Metals, mainly they are heavy. We have some exceptions, example about sodium, potassium, magnesium, while the non-metals, they are generally light in weight. Metals, they are hard, while the non-metals are, some of them, which are the solid one, they are hard, but they are brittle somehow. Metals, as we know, they are conductors of heat and electricity. They are good conductors. We have some exception, example lead. Mainly, most of them, they are good conductors of heat and electricity, while the non-metals, they are bad conductors of heat and electricity. Exception, example about this, graphite. Metals, they are ductile and malleable, while non-metals, neither ductile nor malleable. They have a high melting point. Their melting point and boiling point, they are high, while the non-metals, they have low melting and low boiling point. They produce ringing sound and collision. They don't produce ringing sound and collision. They are lustrous and can be polished, while the non-metals, they are non-lustrous and can be polished. Moving to the atoms, this is the atomic representation. Whenever I told you to write an atomic representation, this is the symbol to represent carbon, oxygen, hydrogen, nitrogen, phosphorus, potassium, calcium. This X. A represent the mass number or the number of nucleons, while Z is the charge number, which is called the atomic number. As I said, symbol X represents an element. It can be lithium, chlorine, sulfur, potassium. N is assigned to the number of neutrons. So capital N is assigned to the number of neutrons, mainly they are found in nucleus. So A, which is the mass number, it's equal to Z, which is the atomic number, plus capital N, which is the number of neutrons. Okay, let's see an example here. We have an example about carbon, which has a mass number A, it's equal to 12, and Z, it's equal to 6. A nucleus contains Z protons and A minus Z neutrons. So A equals Z plus N. Then a mathematical calculation and equation, and it's equal to A minus Z. Whenever Z comes to here, we have to change the sign. A minus Z, so 12 minus 6, it's equal to 6. Okay? All matter of universe, living or they are inert, are made of particles that are called atoms. Atom has two parts, a nucleus and electrons that move around the nucleus in a rapid movement in the electron clouds. The nucleus is made up of positively charged, they are called the protons, P+, and neutrons, symbol N, 0. These particles that make up the nucleus, they are called the nucleons. The electron cloud is made up of negatively charged particles orbiting around the nucleus. So atom is composed of electron cloud and nucleus, as seen here in this diagram. Electron cloud is composed of electrons, symbol E minus. Protons, they have the symbol P plus, neutrons, and 0 or N. Okay? So we have in a neutral atom, you have to say this. In a neutral atom, you have to say this whenever you have to calculate. Z is equal to P plus, it's equal to E minus. And here we have isotopes. What are isotopes? Isotopes are elements that have the same atomic but different mass number. Here you have to study some of these molecules. Some molecules you have to study: molecular elements and molecular compounds. Hydrogen gas, H2, oxygen, O2, nitrogen, N2, chlorine, Cl2, ozone, O3, neon, it's Ne, small e, water, H2O, carbon dioxide, CO2, carbon monoxide, CO, ammonia, and H3, hydrochloric acid, HCl, we have sulfuric acid, H2SO4, sulfuric dioxide, SO2, methane, CH4, ethylene, C2H4, acetylene, C2H2, butane, C4H10, octane, C8H18. According to the type of atoms making up the molecule, there are two types of molecules. We have homoatomic and we have heteroatomic. Homoatomic is made up of identical atoms. Example about this: H2, N2, O2, F2, Cl2, Br2, I2. They are made of identical atoms. While the heteroatomic is made up of different atoms. H2O is heteroatomic, composed of hydrogen and oxygen. Carbon dioxide is composed of carbon and oxygen. Methane, CH4, composed of carbon and hydrogen. Ammonia, NH3, sulfur dioxide. According to the number of atoms making up the molecule, there are three types of molecule. First, according to the type of atoms. Here, according to the number, we have mono, di, and poly. Monoatomic is composed of only one atom. Example: helium, neon, argon. While diatomic is composed of two atoms: H2, O2, CO, HCl. Polyatomic made up of three or more atoms: H2O, H2SO4. There are examples of polyatomic. What is atomicity? Whenever I talk about atomicity, I'm talking about the number of atoms making the molecule. For example, H2 is composed of two hydrogen, so atomicity is 2. H2O, 2 hydrogen plus 1 oxygen, so 2 plus 1 is equal to 3. H2SO4. Okay, H2SO4, how many hydrogens do we have? 2 hydrogen plus how many sulfur? 1 plus how many oxygen? 4. So 4 plus 1, 5, plus 2, it's 7. Here is 7. Okay, let's start with our questions. Question number 1, determine the electron configuration of each of the following cases. Carbon atom is found in the second row and in column 14. The second row means that it has two energy shells. So it has K and L. K and this is L. In the column 14, so it's group 4. It has 4 as the valence electrons. So we have here 4. In order to move to L, K should be full. So it's filled by 2. So it's K2, L4. Magnesium atom has a mass number which is equal to 24 and has 12 neutrons. Here we have to make some calculation. All of you know that A is equal to Z plus M. We have A, this is 24. We have M, it's 12. So we have to calculate Z. Z is equal to A minus M. It's equal to 24 minus 12. This is equal to 12. So what's the electron configuration? K2, L8, M2. This is for magnesium. Lithium has 1 valence electron and 2 energy cells. 2 energy shells or 2 energy levels. This K, this L has 1 valence electron. So we have only 1 valence electron. On the last shell we have only 1 electron. So it's K2L1. Fluorine atom has the following nuclei. This is the mass number and this is the atomic number. Here we have to calculate. So it's K2L7. Silicon atom, which is found directly below carbon atom in the periodic table. Below carbon atom in the periodic table, they have the same group. They have one more electron shell or energy cell. So it's KL. We have to add 1 over this. KL, here we have M. Same group, so they have the same valence electrons. So 4. Here we have, in order to be full, we have to move to M. So we can't move to M without the full mark for L. So it should be 8. Here we have 2. So it's K2, L8, M4. Boron atom which has valence shell L. Valence shell L, so we have K, L. And valence electron is equal to 3. So this is a 3. In order to move to L, K should be full. So it has to be 2. Oxygen atom which has an isotope O17 of electron configuration K2L6. Isotopes, they are atoms, they are elements that they have the same atomic number but different mass number. So they have the same Z. This K2L6, this is Z. So they have the electron configuration K2L6. It doesn't differ. Okay? Move to the second question. Second question. The formula, is for ethylamine. The formula of ethylamine is C2H5NH2. This is the formula. Name the elements that are present in this compound. We have carbon, the first carbon. We have hydrogen, and we have nitrogen. These are the elements present in this compound. Indicate the atomicity in one molecule of ethylamine. Atomicity, we have to count them. How many carbons we have? 2, so it's 2. Plus, how many hydrogen? 5. Plus 2, it's 7. Plus 1, so it's 7 plus 2, 9. Plus 1, it's 10. This is the atomicity of ethylamine. Determine the number of hydrogen in 9 molecules of ethylamine. 9 molecules of ethylamine. So, number of hydrogen in one molecule. How many hydrogen do we have? Here we have 5, and here we have 2. How many molecules? How many atoms, hydrogen atoms? We have 7. So, in order to calculate this, 9 molecules. In one molecule, we have 7. In 9 molecules, so it's 9 times 7. It's equal to 63. Determine the number of molecules of ethylamine that contains 14 carbon atoms. 14 carbon. In one molecule, we have 2. How many molecules of ethylamine to have 17? In one, we have 2. And how many molecules we have? 14. We can make a simple calculation. 14 divided by this number, which is 2. So 14 divided by 2. So we need 7 molecules of ethylamine. Okay. Moving to question number 3. Write the formula of the following compound, listing the elements in the given order. So let's start with the first one. First one, say dinitrogen oxide is an atmospheric pollutant. It's composed of 2 nitrogen atoms and 5 oxygen. 2 nitrogen, so it's N2. 2 should be down like this. And 5 oxygen atoms. Oxygen atoms, so it's O5. That's their formula. Sulfuric acid is composed of 2 hydrogen atoms. Start 2 hydrogens is H2. 1 sulfur, it's S. 4 oxygen, so it's O. H2SO4, since we have 4 oxygen. Baking soda is used in baking. It's composed of 1 sodium. What's the formula of sodium? It's Na. 1 hydrogen, this is H. We have 1 carbon, it's C, and we have 3 oxygen atoms, so it's O3. That's the formula. Acetic acid or ethanoic acid is the main constituent of vinegar. It's composed of 2 carbon atoms, so it's C2. 4 hydrogen atoms, 4 hydrogen is H4, and 2 oxygen, O2. The formula of ethanoic acid, it's C2H4O2, or we can write in another way, CH3COOH. Whenever we see COOH, it goes for an acid. Whenever we see at the end OH, it goes for alcohol. So C2H4O2. Let's see if this is the same. How many C's do we have here? This is 1, this is 2. How many hydrogen? This is 3, and this is 1, it's 4. How many oxygen? 2, and this is 2. Tobacco smoke consists mainly of nicotine, which is composed of 10 carbon atoms. 10 carbon atoms, so it's C10. 14 hydrogen, C10H14. How many nitrogens? 2, so it's N2. Moving to question number 4. Both isotopes of boron, B10 and B11, are used extensively in the nuclear industry. The table below shows the percentage abundance of these 2 isotopes. This is the atom B10.5 and this B11.5. As you notice here, they have different mass number, but they have the same atomic, which is 5. Percentage of relative abundance, it's 80, and here is 20. Calculate the number of neutrons of each atom. For B10.5, Number of neutrons is how much? Number of neutrons is A minus Z. A minus Z. So it's 10 minus 5. So here it's 5. 5 neutrons. Here it's 11 minus 5. So it's equal to 6. Represent this table in a circle graph. First, you have to draw a circle. This circle, you draw it of a radius, maybe 4, 5, 6 centimeters as you wish. First step, you have to draw the radius. For example, this 80%. The circle represents 360. So 360 degree represent 100%. How many percent we have? We have 80%. We have to calculate it and we have defined the answer in degrees Celsius. In degrees, sorry. So we have to calculate it in degree. Maybe it be like this. Okay, you have to calculate the measure. The same way in the second way for 20. So you have to calculate for both of them. Write the electron configuration of the boron atom. Electron configuration, we have 5 Z, so it's K2, L3. Identify the location of boron atom. How many electrons did he have in the valence shell? How many valence electrons? 3. So it's group number 3. While which period? It's period or row which is number 2. Why? Because we have 2 valence shell, 2 energy levels. Okay, thank you.